Wonderful. I'd like to introduce Owen from NEAR. He's going to be talking about secure cross-chain transactions. Take it away.
This is my work. Hello. Yes. Can you turn the lights down a little bit? Is that possible?
Yes.
Yes, thank you. Yeah, so, as you said, I'm Owen. I'm with NEAR. I'm developer relations contributor. And today I'm going to be talking about chain signatures, chain abstraction, all that good stuff. Yeah, like I said, I'm developer relations engineer. I'm also co-founder of Vex Esports, which is just an esports application building on NEAR. And we decided to build on NEAR because, to be honest, it has the best tech. And this is me, and that's my online identity. So I'm going to complain for a little bit. So blockchain right now is a really fragmented experience. I need to have like at least half a dozen wallets to interact with all the big chains and all the big applications. And when I'm building an application, I basically have to decide where I'm going to build my app. And by doing so, I'm very limiting my total addressable market. And there's also siloed liquidity. So say I'm very active on NEAR, but I really want to tap into the liquidity on Ethereum, which is just huge because NEAR's liquidity isn't too high at the moment. But I just can't do that, right? As of now. And also, yeah, if I trade quite a bit on Arbitrum, but I get paid on NEAR, so my process is basically taking my funds from NEAR over to Binance and then swapping to Ethereum, then sending to Arbitrum, and then swapping from Ethereum to the token I want to buy. And it's a pretty laborious process. And if I wanted to make it more secure as such, I could use a bridge. But these bridges, the user experience is inconsistent, and there's been a lot of hacks in the past. So very fragmented, not very nice experience right now. But don't you worry, there is a solution. You just have one wallet, one NEAR account that can sign transactions on any chain, whether that be Bitcoin, Solana, EVM, Cosmos ecosystem, you name it, you can do it really. As long as it has some standards of like public keys. So even if you're setting up your own new chain or a new chain comes out, you don't have to integrate this technology. It's already integrated by default. So what we're trying to do here is create a unified experience where you don't have to have all these wallets and you just log in to one NEAR wallet from one place and be able to interact with all these different applications. So you know what it is, but how does it work? So basically it works through multi-party computational programmable MPC, and it uses threshold cryptography. So it gets a little bit complicated here, but basically you sign a transaction on NEAR to a MPC contract saying that I want to send a transaction over to Ethereum. And there's like an N number of MPC nodes, and then like 3/5 of them or whatever have to jointly sign this transaction without revealing or storing the private key in one place. And once you have that signed transaction, it comes back to you, back to your NEAR account, and then you send that over to a relayer, which sends it to the target blockchain. So if I want to send it to like an Ethereum application, or I want to send Ethereum or whatever. And you have addresses on all these accounts, all these chains, just from one near account. And that works by very, very similar to like HD paths with like hardware wallets. So, you know, with like a hardware wallet ledger, you have one seed phrase, but you can have multiple accounts derived from that. Well, it basically works the same. So you have one near account, you chuck in some metadata like 1, 2, 3, 4, 5 or Owen or whatever, and that derives a different address which is tied to your near account. And on each of these addresses, you can store their native tokens or hold NFTs or whatever like you could with a normal account. So what can you actually do with it? It's enabling DeFi on Bitcoin, as in you can have an account with an ordinal on, and you could use this ordinal. You could swap it, or you could use it as, say, as collateral on a lending protocol like Aave. And like I said before, you could create a unified open web experience from a single gateway. So you just have this one gateway, this one website where you log into your account and you just interact with any application without having to remember a load of have a load of seed phrases written down. You just have one account, sign in, transact, not have to care about anything. You can swap Bonk on Solana for Link on Arbitrum. You can do many crazy swaps that you could just not do before without like bridging and having to burn tokens and reinstate new tokens on other chains. So it's really quite simple in the end of the day. But let's go even further than this. So to make it more simple, we can have fast auth, which is basically you can log into your one near account that has access to all these other accounts with biometrics, so like a face scan or email and password. And then instead of having to hold like Ethereum and Solana and whatever to sign these transactions on these target chains, you just have near, like the near token, and this swaps it to Ethereum for you and pays the gas. So you don't have to care about all these tokens. But maybe you don't want to even hold near at all. So you want to create an even more Web 2 experience, but have all the greatness of Web 3 behind it. You can pay for your users' gas with meta transactions. We've had this for years. So you don't have to pay for any transactions on any chain, basically. The application itself pays for it, or a third party. All right, let's, so I'm going to show, like, can I swap over to this? Hello? Is this working? Yes. Right. So I'll do a bit of a demo, just like a simple example. So if you come over to like your browser, just put in chain signatures. Let's see, I've been there already. And we'll see like the near docs is the first one that'll come up. And we have plenty of documentation on this. So there's an example repo here which guides you through what you need to basically send a transaction and derive an address. So we'll just open that. And it's this near multi-chain example. I've already gone ahead and cloned this and just run npm install and npm run dev, and you will be presented with this application. So I can just go in, log in with my near account. Put my password in here. I'll connect one of my wallets. This is on testnet, by the way. So, yeah, this is the application here. So you can see I'm logged in on my near wallet, and I can select what chain it is. With this example, it's just Ethereum and Bitcoin. So this part here is showing my address on Ethereum, and this bit here is the like derivation path as such. So if I want to use more addresses, I can change this to whatever, and a new derivation path will create a new address, and you can have like near infinite amount of these. So I'll put it back to test because I have some funds on this account, and then I can put in which address I want to send it to. So I have another MetaMask wallet here, and I want to send some Ethereum to this account by using my near account. So I'll copy that address, I'll paste it in there, and so I'm requesting a signature, which is calling to the MPC node to create this signature and like sign it jointly, and then it's going to return it back to me, and then I can decide to broadcast it. This takes a little while. There we go. So it's been signed and it's ready to be relayed. So I'm going to relay it now to Ethereum, and it should give us a valid transaction. There, successful. And it'll even give us a what do you call it, Explorer URL. So I'll put that in, and we can see that I sent 0.01 ETH to that account, so it should appear in my MetaMask. I think it was at 1.6. Yeah, it just went up by 0.01. So you can expand this model to like Solana, Ethereum, Bitcoin, Doge, whatever you want. And I'll just talk a little bit through more of the code, how this works. So the concepts are somewhat difficult to grasp when you go deep into it, like how does the MPC work? But the code is really quite simple. It's just, I'm a bit of a JavaScript hater, I can't lie, but this is just simple JavaScript. So this is the file that lets you interact with Ethereum. So we have this file. It's only like 100 lines long, and we just have this Ethereum class. We have a function or a method, I guess, that will derive the address. So derive the Ethereum address from the near account. And to do this, you just input the account ID. So either the account I'm logged into, or you could even do it so instead of typing an Ethereum address, I could type in another near wallet address, which is a named address. So I can send it to bob.near or whatever, or bob.testnet. And I don't have to remember this Ethereum account name. And I just send that over, and it'll send it to their actual Ethereum wallet, as long as you're using the same derivation path. And then you can have some other methods that help you along the way, tell you the gas price, get the balance of the account. And then here we come to the create payload. So when you're having the transaction, it's sort of like two transactions in one. So it's like a near transaction, and within that transaction is the Ethereum transaction encoded. I think it's like in base 64 or whatever. And that calls the MPC contract to jointly sign it. They each sort of have a part of the private key to do it. Oh yeah, you construct the payload before, and then you request the signature, which is this method here. And then once you have the signed transactions, you send that to the relayer, which bumps it over. But you can just put this all in like, you can call them all in one, so you don't have to like sign and then send the transaction. That was just really for demonstration purposes. You could just do it all in one call. So I'll go back to here. How long do I have left, sorry?
5 minutes.
5
Plus
minutes.
some questions.
So I'll talk about like a high level example here. So if I want to swap, say, like I said, bonk for a link on Arbitrum, well, I'll use more simple. I want to swap Bitcoin for Ethereum. I can create a contract on Near that has these addresses, and it has like one Ethereum address or multiple Ethereum addresses, and it also has a list of Bitcoin addresses. And you set up a map, and in this map it says Owen has this Bitcoin address, and I can interact with this Bitcoin address. I can send funds, I can retrieve funds, I can get an NFT if I want, and it's registered to me. No one else can access that because I've thrown away the keys to this contract. And then there's also an Ethereum account, which is owned by someone else. And to swap these tokens, what you do is you just change the Bitcoin address, you put that in someone else's map. So I take the Bitcoin address and I just put it in Bob's list of addresses, and Bob gives me his Ethereum address, and that's just simply swapped it. But you can also do another way, like Near accounts can actually be turned into NFTs themselves. So you can have a Near account with 100 different tokens on 10 different chains, and you can turn these accounts that have access to these other accounts on other chains and send them to whoever you want, which I think is really quite cool. And there's an application called NameSky, which automatically turns these into NFTs for you to send. So we have two bounties here. The first is to do with chain signatures, which I've just been going on for about 15 minutes. So just use near chain signatures however you want to create any cool application. We want to see the coolest thing. We don't care if it's fully complete, like it should be workable, but we just want to see what crazy ideas you can come up with. But like I said, I'm a bit of a JavaScript hater, so if you want to do something else, you want to create a contract in Near, you want to use account abstraction or whatever, you can just integrate any part of Near's stack for a bounty. So whether that be front-end components stored on chain, whether it be back-end, whether it be data availability, and more. There's a lot of layers to the Near tech stack. So here's the QR. It has a link to everything you should need. Go ahead and scan it. We also have like a group chat there and resources. I think we also have a link to, we call it a shard dog, where you can just create it, set up a Near account, and it'll give you either some Near tokens or some testnet tokens to deploy. But we've got two DevRels here. I'm in my cool purple hoodie, so I'm quite easy to find. But we have a booth downstairs. Just come and ask us any questions. We're happy to help. I'm really excited to see what people are going to build. And yeah, that's it, unless we have some questions. But I'm happy to take questions outside as well.
Thank you very much. Does anyone have any questions for Owen? Yes.
So I'm wondering a bit about the use case that you mentioned before. So swapping Ethereum with Bitcoin, and you said that in that use case you threw away the private keys. How can then the one who receives the Bitcoin use them for anything?
So what I mean basically is you as a developer, you set up a contract that just basically has a map of these addresses and who these addresses are tied to. And you might be a good developer and you've tested this contract a lot, so you know it works. So you don't want it to be, because if you still had the access keys to it, you could sort of control the accounts. So you don't want it to be custodial. So once you're confident with it, you throw away the access keys, you burn them, so you can't have control over these accounts. But how you structure it is that you have a function that you say it says Owen has control over this Ethereum address. There's a function that I say input the address I want to control and what I want to do with the address. I attach the transaction, like send Bitcoin or buy an ordinal or whatever, and the function or the method will check my account, check my signature to make sure that it's actually me who is wanting to do that transaction. But if it's someone else who the transaction isn't associated with, it will just deny and it'll be a void transaction. But when you swap the accounts, then I will no longer have access to that method, but the person receiving it will. Did that make sense?
Amazing. Thank you so much. Final round of applause.
Thank you. Yeah, feel free to ask me any questions afterwards. Cheers.